KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Today we are going to discuss about kinematic equations for uniformly accelerated motion. Kinematic equations for uniformly accelerated motion. Right? Okay. Before going to discuss these kinematic equations, first we have to understand what is meant by uniform acceleration. Right? Okay. Before going to see this uniform acceleration, first I will repeat what is meant by acceleration. So, in simple manner, acceleration is the rate of change of velocity. Otherwise, acceleration is the change in velocity in unit time. Acceleration is the change in velocity in unit time. Acceleration is a vector quantity. The SI unit of acceleration is meter per second square. CGS unit is centimeter per second square. Okay, right. Now, what is meant by uniform acceleration? What is meant by uniform acceleration? See here, if a body covers equal amount of change in velocity, if a body covers equal amount of change in velocity in equal intervals of time, then it is said to be moving with uniform acceleration, however the small intervals may be. I will repeat once again. If a body covers equal amount of change in velocity in equal intervals of time, so please be concentrate. While defining uniform acceleration, I am talking about change in velocity. Change in velocity. I am not talking about velocity, I am talking about change in velocity. Okay, right. So, uniform acceleration means if a body covers equal change in velocity in equal intervals of time, if a body covers equal change in velocity in equal intervals of time, however the small intervals may be, however the small time intervals may be, then it is said to be moving with uniform acceleration. Please try to understand the importance of this definition, uniform acceleration, which is very important to this entire topic, that is. Okay, right. So, when a body covers equal amount of change in velocity in equal intervals of time, however the small intervals may be, then it is said to be moving with uniform acceleration. Uniform acceleration. Okay, right. See here. From the definition of acceleration, you know very well, just now I told you, acceleration is the rate of change of velocity. Otherwise, acceleration is the change in velocity in unit time. Change in velocity in unit time. So, you know that formula also, A is equal to V minus V naught by T. A is equal to V minus V naught by T. So, A is the acceleration, V minus V naught is the change in velocity. V naught is the initial velocity, V is the final velocity, T is the time. Right? So, from this formula, what is that? A is equal to V minus V naught by T. We can write this one. So, both are same. So, from the definition of acceleration, we can write v is equal to v naught plus at, v naught plus at. So, it is like equation number 1, it is like equation number 1, okay, right. See this graph, please try to understand the graph clearly. So, we took time on x axis, velocity on y axis. So, the body has some initial velocity v naught, then it is final velocity. So, this is v minus v naught. So, this is the curve, this is the graph, this is the curve. So, this is the area under the curve. So, the red light indicates this is the area under the curve, but shaded in two different ways. One is like this one is like this. Why? Because this area is the combination of triangle plus rectangle. I will repeat once again, this area is the combination of triangle and rectangle, okay. So, ABC is the triangle and next OACD is the rectangle. So, this is about graph. So, this is the graph for a body moving with v naught initial velocity and will reach to the v final velocity in certain period of time, that is from 0 to t, okay, right. So, from this graph, after understanding this graph, we are going for next step. See here, from the above graph, area under the curve between instants 0 and t, area under the curve between instants 0 and t is equal to area of triangle ABC plus area of rectangle OACD, right. So, what we are doing here, we are calculating area under this curve. So, area under this curve is the area of this triangle plus area of this rectangle. Area under this curve between instants 0 and t, between instants 0 and t is equal to area of triangle ABC plus area of rectangle OACD, okay, right. You know the formula of area of triangle, that is half into base into height. You know the formula of area of rectangle, that is length into breadth, okay. See here. So, going to the next step, continuation to this, right. So, this is the statement we are writing from graph, right. Just we have to cross check whether it is correct or not, okay. So, we are trying to find out this area. This area is the sum of area of this triangle plus area of this rectangle, okay, right. See here, that is equal to, this is the area of triangle, half into base into height, half into base into height, right. This is the triangle, no, see this is the triangle, this is the base, v minus v naught is the base, this is the height, t minus 0, because the initially it is 0 seconds, time t is equal to 0, finally t is equal to t. So, t minus 0 means t will come. So, that we are writing here 1 by 2 into v minus v naught into t plus, this is what rectangle. So, for this rectangle, length into breadth, length into breadth. So, it is v naught, it is 0, right. So, v naught minus 0, that is v naught. So, here v naught into t, breadth is t. So, this is the area under this curve, this is the curve. So, area under this curve will be like this. So, it is a mathematical form. It is a theoretical statement it's the theoretical statement we have written here. The same thing will be in mathematical form, 1 by 2 into v minus v naught into t plus v naught into t. So, this is like equation 1, it is from the definition of acceleration. It is equation 2, this is the mathematical expression we are getting from this statement, right. Next, area under velocity time curve gives displacement. So, this already we know from last class. So, in the last class I told you 3 important points. One is The slope of displacement time graph gives velocity. The slope of velocity time graph gives acceleration. The area under velocity time graph, the area under velocity time graph or curve, area under velocity time curve gives displacement. Because when we are going to find the area under velocity time curve, so area means like length into breadth, no. So here we have to get velocity into time. You know very well, velocity is equal to displacement by time. So that velocity into time is equal to displacement. Velocity into time is equal to displacement. So area under velocity time curve gives displacement. Therefore, because what is this? See here. What is this? This is velocity time graph. This is velocity time graph. We are finding area under this velocity time graph. So it is velocity time graph, ma. It is velocity time curve. So we are finding area under this curve. We are finding area under this curve. So it is equal to the displacement. So that we are writing here x. So x giving x is the symbol to represent displacement here. So that we are writing. So area under the curve between instants 0 and t is the displacement, because it is velocity time graph. Displacement is equal to 1 by 2 into v minus v naught into t plus v naught into t. Same thing we have written here, but here we added this is the displacement, because from this information, we can write here x is equal to, so that this is the rest of the part is same. So it is like equation number 3. Okay, right. Next, we know that v minus v naught is equal to at. See here, it is equation number 1 now. V is equal to v naught plus at. So you take this v naught to that side, then what will happen? V minus v naught is equal to at. V minus v naught is equal to at, right? So here we know that v minus v naught is equal to at. Okay. So here in place of v minus v naught we have to write at. So already t is there. So please observe carefully, 1 by 2 at into t. So 1 by 2 at square, 1 by 2 at square plus this is same v naught into t, we are writing as it is v naught into t. So x is equal to, therefore x is equal to 1 by 2 at square plus v naught into t, right. The same thing we repeated here as it is, x is equal to v naught into t plus of at square. So it is equation number 4. Equation number 4. So this is equation number 4. X is equal to v naught t plus of at square. Okay, right. See here. See the next one, ma. Equation 2 can also be written as. So what is equation 2? This is equation 2. That is what? 1 by 2 into v minus v naught into t plus v naught into t, right. So this one also I can take, because just we have written x, right. So either equation 2 or 3. So either equation 2 or 3 can also be written as like this. X is equal to v plus v naught by 2 into t. X is equal to v plus v naught by 2 into t. How? You just see here. It is vt minus v naught into t, no. Mathematically, if you separate this, so how can we write here? 1 by 2 vt minus 1 by 2 v naught into t plus v naught into t. So what will happen? 1 by 2 vt plus 1 by 2 v naught into t will come. So that you can write it as x is equal to v plus v naught by 2 into t. X is equal to v plus v naught by 2 into t, that is equal to average velocity. This is the average velocity. So I put here a bar symbol, no, on the top of the velocity, bar symbol is there. Okay. So here v bar is equal to v plus v naught by 2. V bar is equal to v plus v naught by 2. So it is average velocity. So here I have written where V bar is equal to V plus V naught by 2, where V bar is equal to V plus V naught by 2. This is when a body is moving with constant acceleration. Actually, the whole topic is correct when a body is moving with uniform acceleration or constant acceleration. Okay. So, here also again I wrote, that is in the bracket, constant acceleration. So, where V bar is equal to V plus V naught by 2, V plus V naught divided by 2, that is what when a body is moving with constant acceleration, constant acceleration. It is equation number 6. According to our class from starting onwards, it is equation number 6, where V bar is equal to V plus V naught by 2 when a body is moving with constant acceleration. Okay, right. See this from equations 5 and 6. This is equation number 5. This is what? Equation number 6. Equation number 5 and equation number 6. Okay, we can say that is a statement, giving one statement. So, listen carefully. We can say that when an object has undergone displacement x with an average velocity equal to the arithmetic average of the initial and final velocities, right. So, when an object has undergone displacement x with an average velocity equal to the arithmetic average of the initial and final velocities. So, finally, he is saying the same thing, V bar is equal to V plus V naught by 2. So, if you consider the displacement as a function, displacement is equal to average velocity into time, average velocity into time, that only he is saying here. Displacement is equal to average velocity into time when a body is moving with uniform acceleration, when a body is moving with uniform acceleration. Okay, right. Again you see here from equation 1, t is equal to V minus V naught by A. So, it is from where? Here V is equal to V naught plus AT, no, V is equal to V naught plus AT. So, here t is equal to V minus V naught by, same thing we are writing like this mathematically. Next, substitute this in equation 4. Where is equation? This is equation 4, right. So, this is equation 4, this is equation 4. From equation 1 you can write this. So, this we are going to substitute here or otherwise here, right. So, it is after equation 5. So, here this t value we are substituting in equation 5 So, not equation 4, equation 5, because equation 5 comes from definition of average velocity when a body is moving with uniform acceleration. So, this value t is equal to V minus V naught by A, we are writing in equation 5. So, if we have written in equation 5, okay, then x is equal to V bar into t, that is equal to same V bar is equal to V plus V naught by 2 into t is equal to V minus V naught by A, t is equal to V minus V naught by A. So, that we can write x is equal to, it is what, A plus B, it is what, A minus B, just we are multiplying. So, A plus B into A minus B is equal to A square minus B square, A plus B into A minus B is equal to A square minus B square divided by 2A. So, take this 2A to that side, 2AX, and send this V naught square to that side. Finally, V square is equal to V naught square plus 2AX, V square is equal to V naught square plus 2AX. So, this is the expression we got it. Okay, right. So, finally, what I want to say here is, so we derived 3 equations. One is this one. This is just from definition of acceleration. Second one is here, x is equal to V naught into t plus half AT square. X is equal to V naught into t plus half AT square. And the third one will be here. So, these numbers, equations 1, 2, 3, 4, 5, 6, these are the numbers we have given for our convenience. But actually, here we derived only 3 equations. This is the first equation, and it is the second equation of motion, and it is the third equation of motion. So, here I wrote clearly, see here. Finally, we have V is equal to V naught plus AT, X is equal to V naught into T plus half AT square, V square is equal to V naught square plus 2AX. Okay. So, what I am saying is, so whatever we have, suppose for example, this is also one of the small thing, right. So, whatever we have, everything followed by a body when it is moving with uniform acceleration. But finally, importantly, we have three equations. These are the three equations which is satisfied by a body when it is moving with uniform acceleration. So, if you observe carefully, so these are the equations which relates initial velocity, final velocity, acceleration, time, displacement. So, I will repeat once again. These are the three equations which relates the initial velocity, final velocity, acceleration, time and displacement of a body, right. So, when a body starts with either 0 initial velocity or with some initial velocity, after a certain time interval, it may reach or it may cover certain displacement, so that they can expect initial velocity. Suppose if initial velocity is there, if initial velocity is 0, V naught is equal to 0. Suppose if initial velocity is there, we are taking it as V naught. Then certain displacement x in certain time interval t, then automatically its velocity will be increased, it is V. Finally, it has some acceleration. In this situation, what is the situation? Body starts from here and is going to reach this position within the time interval t. So, here its velocity is V naught, for example, V naught is the initial velocity, here its velocity is V. So, meanwhile, it is going to cover x displacement in t interval of time, okay, right. So, in this situation, we are getting these three equations of motion. These three equations are relating the initial velocity, final velocity, acceleration, next time and displacement. So, here I wrote clearly which connects 5 quantities, These are kinematic equations of rectilinear motion for constant acceleration. These are the kinematic equations of rectilinear motion for constant acceleration, okay, right. So, for example, a body starts with some initial velocity. Suppose you know the initial velocity, you know that acceleration and you know the time, then automatically you can find final velocity by using first equation of motion. Similarly, in another situation, you know initial velocity, you know the time of journey, you know the acceleration. Then by using second equation of motion, you can calculate displacement. So, that is the use of second equation of motion. Similarly, you can also calculate the displacement. By knowing initial velocity, final velocity and acceleration. If you know initial velocity, acceleration, time, you can also calculate displacement. Without knowing time, if you know the displacement, also you can calculate final velocity, that is V square is equal to V naught square plus 2AX. V square is equal to V naught square plus 2AX, okay, right. So, these are the equations which connects V naught, V, A, T and X. So, these are the kinematic equations of rectilinear motion for constant acceleration, okay, right. The set of equations, so whatever we have here, these equations are true when displacement is 0 at time is equal to 0. At time is equal to 0, displacement is 0, right. So, then only these equations are true. Suppose if it is not, then we have to go to another form of these three equations, right? For example, here v is equal to v naught plus a into t, x is equal to x naught plus v naught into t plus half a t square, v square is equal to v naught square plus 2a into x minus x naught. So, please observe carefully what is the difference between these three equations and these three equations. There is no change in the case of first equation of motion, whereas for second and third we added a term, we added x naught here. Here also we added x naught. So, it is the difference in the displacement x minus x naught, but here we added x naught. You can take this x naught to this side also, then automatically you are getting the resultant displacement. So, x minus x naught is equal to v naught into t plus half a t square. Similarly, here also the same thing will come, right. So, when the displacement of a body is not 0, at time is equal to 0, then these are the kinematic equations of motion. Kinematic equations of motion for a body moving with constant acceleration, moving with constant acceleration, okay, right. So, for the above equations, displacement exists, that is x naught, okay, right, that I already told you. If a body is moving with constant acceleration, if a body is moving with constant acceleration, then only the above equations you can apply, because this topic is very important. In this this class we derived three equations of motion. V is equal to v naught plus at, x is equal to v naught into t plus half a t square, v square is equal to v naught square plus 2ax. These three equations we need very important, and we need mostly for problems, right. So, we have a lot of problems regarding these three equations. And one more thing is, these three equations are the equations of motion of a body moving in a straight line. So, when a body is moving along a straight line, otherwise the kinematic equations of a rectilinear motion for constant acceleration, okay, that is, okay, right. So, that is about today class.